This section is about changing the graph of a function. Say we have a graph of a function, say here in case y equals absolute value of x. We're going to shift it up or down or left or right by changing the formula a bit. For example, here y equals absolute value of x. If you add k to the graph, to the function, y equals absolute value of x plus k, it'll shift the graph up or down. So here's the graph of y equals absolute value of x. Here we add 1, y equals absolute value of x plus 1. This will be absolute value of x plus 2. This shifted downwards. 1 is the graph of y equals absolute value of x minus 1. This shift downward for y equals absolute value of x minus 2. So f of x plus k, y equals that. It'll shift the graph of y equals f of x up k units, down if k is negative, up if k is positive. Here we have y equals absolute value of x minus h. Here we subtract h inside the absolute value graph. What this does is basically delays the graph by h units. So it shifts the graph left or right. To the right, if you're subtracting by a positive number. To the left, if you subtract by a negative number, in other words, add 1. So here, this v is the graph of y equals absolute value of x. Y equals absolute value of x minus 1 is 1 unit delayed, so we shifted over 1 unit to the right. Here's the graph of y equals absolute value of x minus 2, which is the absolute value graph, shifted 2 units to the right. Here's the absolute value of x plus 1. That plus advances it, so it's 1 unit earlier, like this, shifted left. Y equals absolute value of x plus 2 is shifted left 2 units. So y equals f of the quantity x minus h. That shifts the graph of f right h units if h is positive, left if h is negative. And if we do both, y equals f of the quantity x minus h, all that plus k, that'll do a double shift. It shifts the graph right h units if h is positive, and up k units if k is positive, down and left if otherwise. Okay, so for example, here's a graph of y equals f of fx. The graph of f of x plus h minus k is moved right h units and up k units, like this. So that's adding and subtracting inside the function, inside and outside the function. Then there's multiplying. Here, multiplying outside the function. A times f of x. What this does is it makes the graph taller. It stretches it vertically. So if a is bigger than 1, it's a vertical stretch. It makes it taller. If a is between 0 and 1, then it's a vertical squeeze. It makes it shorter. If a is less than 0, it flips the graph up or down. So for example, here is the graph of y equals f of x, a sine wave. Y equals 2f of x is stretched to twice as tall. Y equals a half f of x, half as tall. And here, y equals negative f of x flips up for down. So in general, y equals a f of x. What this a does, it modulates the amplitude. Now you may have heard of amplitude modulation. That's AM radio, amplitude modulation radio. The way it works is that the radio tower pumps out this radio signal whose amplitude rises and falls in tandem with the wave that's trying to transmit, namely a sound wave. The trouble with amplitude modulation radio is that in these periods where it's at low amplitude, the signal is vulnerable to disruption by noise. Lightning strikes, electrical equipment being turned on and off, whatever. So AM radio tends to be staticky. And therefore, it's reserved for signals which don't require as high signal quality as all that. So it's good for Morse code and voice transmissions, but not for music. Now let's start multiplying inside the function, f of the quantity b times x. Now, okay, this will affect the graph horizontally, and it'll just like adding and subtracting inside the function, moved right or left, sort of opposite to the sign of the function. Here, f of bx will stretch or squeeze the function opposite from the magnitude of the function of b. So for example, if b is bigger than 1, then f of bx runs through its range more quickly, b times faster. So it squeezes the graph horizontally. And if it's between 0 and 1, then it delays the graph. It makes the function move through its range more slowly. So that corresponds to a horizontal stretch. If b is less than 0, it'll flip left for right. So for example, if here's a graph of y equals f of x, and y equals f of 2x is squeezed in, it runs through its range more quickly, whereas y equals f of a half x is stretched outwards horizontally. And y equals f of negative x is flipped left for right. So y equals f of bx, that modulates the frequency of the graph. And FM radio is frequency modulation. And here the idea is that the radio tower pumps out a radio wave whose frequency gets shorter and longer and shorter and so on, in keeping with the signal it's trying to send, namely a sound wave. And the advantage of FM radio is that it never goes below a certain amplitude, so it's less vulnerable to interference and noise. The difficulty is that it runs through a range of frequencies, so it can't be at a frequency. It has to be in a band of frequencies. That's what they call it, bandwidth. All right, let's see. If this is the graph of y equals f of x, the negative y equals negative f of x flips up for down like that. Whereas y equals f of negative x flips left for right like that. And if you do both, y equals negative f of negative x, it's a flip followed by a flip, which is the equivalent of a 180-degree rotation like that. So for example, graph y equals x minus 3 squared. Okay, y equals x squared is this U-shaped parabola. And x minus 3 means we move the graph to the right 3. So here's the graph, parabola touching down at 3 by 0. Here, graph y equals 1 over x plus 4. 1 over x has this shape called a hyperbola. This plus 4 outside means it moves it up 4. So you still have a hyperbola, only instead of being asymptotic to the x-axis where y equals 0, it's asymptotic to this line where y equals 4. Now here we have graphing negative of x minus 2 cubed. Okay, x cubed, this is this n-shaped graph. Negative x cubed flips up or down like that. This minus 2 means you move it to the right like that. Here we have a graph going from negative 5 by 0, negative 2 by 3, 0 by 0, 2 by negative 3, and 5 by 0. Graph y equals f of negative x plus 3, graph y equals negative 2 f of x plus 3. All right. Starting from here, f of negative x flips left for right from here to here, and up 3 moves it like this. So this is the graph of y equals f of negative x plus 3. Now here for negative 2f of x plus 3, well, we have to flip up for down like this and stretch it by a factor of 2 to get a graph of y equals negative 2f of x. Then add 3, you move it up 3 units, and here it is. Okay,